for the function f(x) equals x cubed minus 2x squared plus x plus 3. Find the coordinates of all stationary points and state their nature. Stationary points occur whenever f dash x is equal to 0. So let's find f dash x, which is the derivative of f of x. That'll be 3x squared, take 4x plus 1. And for stationary points, we let it equal 0. I need to now solve this equation. It's a quadratic equation. With the 3x squared, copy down the first term. With the 1, copy down the last term. And then I'm looking for two numbers that multiply to 3 times 1 and add to the number in the middle. So multiply to 3 and add to negative 4. Now the pair of numbers that does that is negative 3 and negative 1. Check, they multiply to positive 3, yes, and they add to negative 4, they do. Doesn't matter which order you put those in the middle, but each needs an x on it. Now look at the first two terms and factorise. That'll be 3x outside of x take 1. Look at the last two terms and factorise. Well, there's not a common factor, but there is a negative at the front. So I'm going to take out negative 1. And that will leave x take 1. Now, your brackets should always be the same in this method, and the two brackets are the same. So I can write it as 3x take 1, x take 1 equals 0. And if I solve, here I get 1/3, and here I get 1. So there are two stationary points to this curve. One at x is 1/3, and one is at 1. Now, if we look back at the wording of the question, we need the coordinates of all stationary points. Now, the word coordinates means you need the x value and the y value. So that will be my next step, to find the y value of each of these. Now, the first x value that we got was 1/3. So substitute 1/3 into the equation. 1/3 cubed minus 2 times 1/3 squared plus 1/3 plus 3. We've got 1 over 27 minus 2 over 9 plus 1/3 plus 3. And if you use a calculator, you'll get 85 over 27. Now if I sub in the positive 1, which was my other stationary point, I get 1 cubed minus 2 times 1 squared plus 1 plus 3. And that gives me 3. So I have two stationary points. Therefore, the stationary points are 1/3, 85 over 27, and 1/3. So we found them. Now we need to state their nature. So here's the original function. We'll go back to its derivative, and that was 3x squared take 4x plus 1. And using that derivative, we need to create a sign diagram. So I draw a line, and the 2 points of interest are 1/3 and 1. And I want to test what sign the first derivative is at each of these regions that I've divided that line into. So if I choose a number that's less than 1/3, a nice easy one would be 0. And I sub it into f dash x. And when I sub it in, I get 0 minus 0 plus 1. So this is a positive number, and that's all I need to record there, that this region, the first derivative, is positive. Now if I choose a number in between 1/3 and 1 to represent the middle region, I might choose a half. And that would be 3 times a half squared minus 4 times a half plus 1. 3/4 minus 2 plus 1. So 3/4 minus 1 is -1/4. That's negative. So all I need to know about that, just the sign of it. And if I choose a number from the right-hand region, a number bigger than 1, I could use 2. That would give me 3 times 4 is 12, minus 4 times 2 is 8, plus 1 is 5. Positive number, so positive region. Now this is the first derivative, so a positive gradient goes that way, a negative gradient goes that way, a positive gradient goes that way. First derivative is gradient. And I can see now from my sign diagram that it's a maximum at x equals a third and it's a minimum at x equals 1. So in my final response to this question, I would say therefore 1/3 85/27 is a local maximum, and I would say that the point 1,3 is a local minimum. And that's what it means by stating the nature of stationary points. Is it a maximum? Is it a minimum? Or sometimes we get something else called a point of inflection.